Hi everyone, welcome to our live workshop. So as a part of module 2 about experiment tracking, you have already seen or started seeing the experiment tracking module, and you have seen MLflow. MLflow is not the only tool, as we mentioned in the videos and the lectures. There are other tools for experiment tracking. And today we will see how you can track experiments with weights and biases. And today we have Soumik. Soumik works for weights and biases, and today he will show us roughly more or less the same content as in the module, plus some extra stuff. And probably right now I just need to shut up and give the floor to you. So please, please start. And yeah, hi everyone.
Hello, everyone. So today, basically, we will be taking a look at experiment tracking with weights and biases. And you can actually follow along my presentation. You can basically scan this QR code or just copy this link and paste in your browser, and you can follow along with this presentation at your own pace. You can also find all the code. There will be some hands-on demos that I'll be doing, and you can find all of those codes in this particular repository, and you can scan this particular QR code to get that repository. So before we start, hi everyone, I am Soumik Rakshit. I work as a machine learning engineer at Weights and Biases. I also am a Google developer expert for JAX and FLAGs. I do a lot of things which majorly include developing tools for ML practitioners, developing MLOps pipelines for products like MonAI, NVIDIA GameWorks, Keras, JAX, and a lot of other open source tools. I have been training computer vision models for a long time, and right now I am working on training computer vision models on TPUs. I actively contribute to the Keras ecosystem, which is another ML framework I love very much. I play a lot of video games. I am currently playing The Legend of Zelda Tears of the Kingdom. And if you want, you can follow me on GitHub or Twitter, and you can DM me on Twitter as well. So I have already mentioned, and like Alexia has already iterated, that this module is all about weights and biases and how we do things using weights and biases. So before jumping exactly into the nitty-gritty and the details of experiment tracking with weights and biases, we will just take a brief look at what weights and biases is. So we basically like to call ourselves an MLOps platform, and experiment tracking is basically one of the many offerings that we provide. So if you sign up to Weights and Biases, you can get access to experiment tracking. You can get access to artifacts for dataset and model versioning. You can get access to tables for interactive data visualization, collaborative dashboards via reports, hyperparameter optimization, automated ML workflows, and many more. I'll be covering some of those in this particular demonstration. And if you're wondering how to use weights and biases with any particular ML framework or any kind of other environment, you can basically check out. We are integrated with almost all open source frameworks and libraries that are out there. We are also trusted by the leading ML teams across the globe, including OpenAI, Meta, NVIDIA, and many more. So now that I have kind of established what this whole thing about weights and biases, what we do at Weights and Biases. So let's get down to the crux of this demonstration. It's all about experiment tracking. But before getting into experiment tracking in the context of machine learning experiments, we first have to understand what are machine learning experiments after all, right? So machine learning is basically a highly empirical field of work. Like it's unlike traditional software development. There's a lot of experimentation going on, and there's a lot of things people do not explain right away. We are not able to explain. So we have to basically do a lot of trial and error basically to find the best suitable model, or say the best suitable set of hyperparameters. So A typical machine learning workflow, since the whole thing is so empirical, a typical machine learning workflow will involve a lot of exploration with data and models, training a lot of models, evaluating the models you're training, fine-tuning some of the models you're training for specific use cases, training a lot of models again. Maybe if your models do not work, you have to try something else. So this highly empirical nature of machine learning demands you to experiment a lot with your workflows. That's why basically we are dealing with ML experiments. But you might pose a question, why do we need to track an ML experiment? After all, we can just, train the models and, kind of take the models and deploy them in our production server, maybe. But, we track ML experiments for three major reasons. One of them is to share results. Basically, you obviously want to share the cool results, the cool ML models that you are training. Also, the thing is that tracking your experiments not only ensure reproducibility. If you wish to reproduce the same model later under a different setting, it's important to keep the experiments tracked somewhere. But also these tracked experiments enable you to take a lot of important business decisions. So we will basically try to take a look at how experiments are tracked traditionally. And, when I basically started working as a machine learning engineer, one of the first things we used to do was, maintain a lot of log files, because there was a lot of models we were training. So there were a lot of log files they were generating. And later, basically, what we would do is parse these log files into, or boil down these log files using regular expressions into, some kind of spreadsheet where we will basically analyze what are the different trends in, training laws, validation laws, our metrics, whatever. Then again, sometimes later we got access to this wonderful tool called TensorBoard. And TensorBoard is a really wonderful tool. It basically, removes this whole barrier of keeping our data logged using log files somewhere, then boiling them down to spreadsheets or something. It basically enables us to log our metrics in real time in an interactive web dashboard. But then again, there are a few problems with respect to TensorFlow, in the sense that it's a little difficult to scale if you are not creating your own TensorBoard hosting service. And also the thing is that it's difficult to compare different TensorBoard experiments together, which make it a big, which makes it basically a nuisance to, share your results with your colleagues, your teachers, your friends, whoever you're collaborating with. So then basically what happens is that you are not doing it alone, right? You are doing it with your team. You are doing it with your teachers. Maybe you're maybe a hobbyist. You're maybe doing it with your friends, or maybe you're participating in a Kaggle competition. So there are more people you're collaborating with, and the more people you're collaborating with, you will soon find out that this approach doesn't scale well. Soon, basically, you will have, your notebooks, your screen grabs of different graphs, your PowerPoint presentation, your Google Docs, your over different email threads, and like soon they leak out into Microsoft Teams, maybe on Slack, sometimes on Discord. Like you won't be able to get a break while you're gaming. But this might be fine for some of the more pain tolerant folks among us, but should we settle for this approach? Let's try to see if there's a better way to do things, to track experiments and to maintain a system of records, as we say. So we will see how a system of record for all machine learning workflows work, or should be. So we have already kind of established the traditional machine learning workflows and how experiments are tracked traditionally. What if all of these things were done by one particular web application for you automatically with minimal invasive code in your ML workflow? Well, that's basically where we come in. So weights and biases is basically you can interpret weights and biases not just as an experiment tracking tool, but as a system of records for all your ML workflows. So the philosophy of weights and biases revolves around two basically concepts. One of them is a run, which is basically equivalent to an experiment, you can say, in your normal lingo. So what we call in the weights and biases paradigm is a run, is basically an experiment. So you basically initialize an experiment. You start an experiment by calling 1b.init, and 1b is basically the client library, the Python client library for weights and biases. And after you have initialized your experiment, you log something to weights and biases using 1b.log. That might be some matrix, some matrices, including your training and validation losses, your errors, your accuracies, and stuff like that. It might be your model checkpoint files, your version directories as artifacts. It might be things, something like rich data, media rich data frames, and a lot more. So like I've been talking about weights and biases for a long time, but now basically what I'd like to do is give you a quick glimpse into what weights and biases is and how you can integrate weights and biases with your ML workflow. I'll basically be showing you the demo over a GCP instance, a VS Code instance running on Google Cloud Platform, but you can get started with the demo using GitHub code spaces. You can run it for free on Gitpod or Google Colab as well. You can simply, I'll share the link to the code once more. If you wish to copy
I've already shared it, so I put it. It's in the live chat and also in the video description. So if you go below the video, you see two links. One link is to this link that you see, and then the other one is to the homework, which we will talk about later. But there are two links already, so go there.
Thank you, Alexi. So basically, you can just go ahead and open up this GitHub repository, and you can spin up a code space here. If I delete this code space, it will show up. Yeah, you can just spin up a code space on main. It will open up a VS Code window on your browser, inside your browser itself, where you can code and run your run the notebooks and other experiments. But for this demonstration, I would stick to a VS Code which I'm basically running on a Google Cloud VM. But there's not going to be any difference with respect to the results you get, irrespective of wherever you run. Right. So first, basically, you can install the dependencies one by one using pip install, but you can also use the requirements.txt file that has been shared as part of this repository, and you can install the repositories, all the dependencies that are needed to run the code in one go.
Just sorry for interrupting you. Can you make your screen a bit larger? Like the letters are quite small. It's difficult to see them. Maybe one more time. Yeah, this is good. Thank you.
This is good. Right. Okay. So first, basically, we will start with importing our libraries, and we will basically be demonstrating the use of weights and biases with a very simple logistic regression, which we will be fitting over the iris dataset. So first, we import all our dependencies. We import the 1B client library. We import pickle, which we will be using for saving our model. We also import the sklearn dependencies, the scikit-learn dependencies, including logistic regression, the function to load the iris dataset, and a couple metrics, which we will be logging to weights and biases. Then basically, before writing any code about loading our data or training our model, what we do is we basically call 1b.init. So let's kind of run this code. I'll just run it. No, I don't want to take a survey. So what I'm basically telling in this 1b.init is that this is the name of my 1b project, and this is the name of my experiment, which is experiment 1. So if I initialize this, it would automatically create my project and create the run itself or the experiment itself. You can see it has already created the project and the experiment itself. And if I go here, I can see the run.
What if I do not have an account with weights and biases yet? It
Very
will
good
probably be
question.
different, right? So I need to do some configuration.
It's a really good question. So if you do not have a weights and biases account, what's gonna happen is you're automatically going to be prompted to create one when you call 1b.init.
Mhm.
So what you basically need to do is, I think there are 2 or 3 options. Like, one is for creating an weights and biases account, one is for using an existing account. Since I already have my weights and biases API key here, it basically caches your API key automatically. You do not even need to worry about going to weights and biases and grabbing your API key or anything like that. So you can just get started, and 1b.init is basically going to prompt you what you need to do to get started.
Mhm. So it will tell me where I get the key, right?
Exactly, it's gonna tell you. So yeah, so basically this is the experiment page that I opened up. You can see that there's nothing much going on because we haven't logged anything here yet. But soon we will see, once we log something, how it looks. And what we are going to do then, basically load the iris dataset. In order to know more about this dataset, you can actually check out the official docs for this dataset in the sklearn documentations. And once I have loaded this dataset, what I'm going to do is define a dictionary, which is basically going to be my model parameters. So one of the things that I was emphasizing when I was talking earlier about weights and biases is reproducibility. So how do you ensure your model is reproducible or not? You ensure the reproducibility of your models by, one of the ways at least you do that is to sync all the configs or the hyperparameters that are there for your experiment. You can log it directly to weights and biases. So what I am doing here is basically defining up parameters, which these are basically 2 parameters for defining the logistic regression model parameters. And I am passing these model parameters to 1b.config, and we will see what happens once we execute this. So if I now go to my weights and biases dashboard, I can already see that there are a couple of things that are being logged. What you are seeing here is basically weights and biases monitoring the performance of your system hardware, as you can see, in real time. So it's monitoring your memory usage, your disk utilization, and a lot of things. And if you are a deep learning user, it's going to automatically monitor your GPU usage, your GPU utilization, and a lot more things about your GPU as well as your CPU. But we are not, we are not intending to harm any GPU during this demonstration. So we just have the normal system metrics of CPU, disks, and network. But if you go to the overview thread, you should be able to see some configurations, or they haven't. Yes, you can see. So one of the first things that you can see here is the repository that is being used. So GitHub is wherever you are hosting your repository. I'm hosting it on GitHub. You can host it on GitLab. You can host it on Bitbucket. It automatically gets detected by weights and biases. You can also see which particular branch or Git hash do I need to check out to basically get access to this particular version of the code which was used to run this particular run. And also you see a few things like what is the version of the weights and biases CLI, what's the system hardware. Like I'm running my experiment on 8 CPUs, that's being automatically detected. It's showing a Python with no main file under command because I'm not running a Python file, I'm running a Jupyter notebook. But if you're running a Python file, the command you are running also gets automatically logged. So yeah, some of the things that we do to make our experiments reproducible.
Sorry. Like if you go back, maybe you probably will go back to this. Yeah. Can you make the font larger?
Oh, sure.
Yeah.
Is that?
Yeah, good. Yeah. Thank you.
Thank you. Good. So now basically what we are going to do is use these model params to basically define a logistic regression model and fit it on our iris dataset and get our predictions and prediction probabilities. Then what we are basically going to do is log a few things, log a few metrics on weights and biases. So I'm logging accuracy and mean squared error. And as you can see, all you need to do is just pass a dictionary to weights and biases log function, and it automatically starts syncing. So what happens if I log this? Let's see if it's showing up or not. It's not showing up yet. Maybe there's something wrong with my internet connection. But we will move on, and we will see once we end the experiment how our dashboard is going to look. So, for a lot of experiments, we need to plot ROC curves, something like confusion matrix or precision recall curves. And often we need to write a lot of Matplotlib code or Seaborn code to do that. And yet, even then, we kind of get, in spite of writing a lot of code to create visualization, we oftentimes get, kind of static graphs. But, weights and biases comes, or the weights and biases integration for scikit-learn comes with a few utilities which you can use to create some interactive charts, which you can use to visualize different aspects of your model or your experiment. For example, this function basically creates a ROC curve. This function, if I execute it, it should create a precision recall curve, and this function should create a confusion matrix. Now, I'm hoping that we will see what happens when we end this experiment, basically. But before ending this particular experiment, we will do one more thing, which is save the model for later use. So we save our model using something called weights and biases artifacts. And you can think of artifact as a version directory. In this case, I don't have a directory. I just have a file. So I basically define my weights and biases artifact of type model. And I just add this logistic regression file, which I have saved using pickledump to my artifact. And I just call 1v.log artifact on this particular artifact. And after executing this cell, after executing 1v.finish, we will just see what happens. So 1v.finish, what it does is basically it logs all your artifacts which are registered during your experiment at once to your weights and biases dashboard. And we will see in a moment how it looks like. Cool. So the experiment has actually ended. So if we go back, we can actually now see that a few things have shown up. So you can see the precision recall curve, the confusion matrix, and the ROC curve has actually shown up for all three classes that were included in the iris dataset. And all of these interactive charts we can get by using just one line of code, which you can refer to the notebook and check out. But more importantly, if you remember, we also logged our mean squared error and our accuracy values to weights and biases. And this kind of shows up as one single value because these are just single scalars, right? But as single scalars, they don't look as they don't give as much as insight as we would like them to give. So let's try something else as well. If you go to the overview, and we can actually see that the summary also has been synced. So we can see the summary of our experiment, the accuracy and the mean squared error all here. So let's do one thing. Now that we have seen an experiment, how to do an experiment tracking, an experiment with weights and biases to track the matrix, let us track one more experiment and see if we can get any more insights. So let's say for this second experiment, I'll first restart my notebook. Let me make a small change to our hyperparameters. Let's say I change this value to 0.22. And then let us rerun the whole notebook again. And we will see how basically we can compare this second experiment with our first experiment.
While it's being rerun, there are a few questions. So the first question is, can we run weights and biases locally?
Okay, in order to run weights and biases locally, you need to get an enterprise license. Otherwise, you cannot do that.
So the free one is only the cloud version, right?
Yes, yes. The free version is only the cloud version.
Okay, and another question is, can we run this locally? So you're running it on GCP instance, right? And it's also possible to run it on code spaces, but can we run this locally? I assume the answer is yes.
Yes, of course. Like the code, you can code anywhere. If you are coding on Windows, if you are on Linux, if you're on Mac, it doesn't matter. It's just a preference of, it's my personal preference to run it in GCP. Nothing else. You can run it on code spaces as well. There's no issues. You can run it on Google Colab. You can run it locally using VS Code or any other IDE you want. That's completely fine.
I think you can run it even on your phone. I've seen people do this.
Yes, I have seen people run it on their watches.
Watches, okay.
Yeah.
Yeah. Did it finish?
Yes. So we can see actually there are two experiment ones. That's because I didn't change the experiment name, but that's okay. I can rename this to experiment 2 currently. And now you can see that the accuracy values and the mean squared error values, instead of them being dots in single dots in a graph, you can, see them side by side. Compare the metrics side by side. So we can see, just changing the value, changing that one C value in the second experiment actually brought down my mean squared error quite a lot.
Why do we have mean squared error though? Like, isn't it supposed to be a classification problem?
Yeah, it's a classification problem, but I'm just trying to demonstrate. Like, if you wish to log mean squared error, you can.
Okay.
But yeah, we will go into the actual, one actual classification problem where we can see, there are specific plots which you can take advantage of as the weights and biases.sklearn offering, which are specific to your classification problems.
Then some people have problems that they don't see some of the charts, heresy and so on, or confusion matrices. I don't know, probably right now we will not be able to debug every single problem that some of you might have. But what's the best way to reach out to get support? Like Slack?
You can reach out to me on Slack.
Yeah, okay. So yeah, just ask a question in Slack in our course channel, and then we'll try to figure out what's wrong and why what you see is different from what you see right now in this video.
Yeah. So yeah, as I was telling, comparing your different experiments together. So you can see even the charts have actually changed to basically show experiment 1 and 2 together. So you can actually see what that particular difference in one single hyperparameter in experiment 2 actually meant in terms of the ROC curve, in terms of the confusion matrix, or even in terms of the precision recall curve. So these are just some few ways, you can quickly get started with using weights and biases as part of your machine learning workflow. And with that, let's jump back to our PPT. And yeah, let's resume from here. So we kind of basically saw how to log some things to weights and biases. And it's all about logging your data, your metrics, your insights, even your models, as we saw right now as part of weights and biases artifacts. But we will see a few different things now, like how we can ask questions to weights and biases about our data and our model. So one of the ways using which we ask questions to our tabular data specifically is by using a lot of pandas operations, by writing a lot of code using pandas, or maybe if you're using something like SQL or NoSQL, in that case, you write SQL or NoSQL queries. So you perform a lot of operations like split, combine, group by, aggregate, and you also need to plot a lot of things. But let's see if we can, find a better way to explore our data set, ask questions to our data set, and even, debug and version our whole ML workflow. So what the next thing that we are going to discuss is about 1b.table, which you can basically think as an interactive data frame with rich media support. And again, I'll just try to demo it. This time, basically, I'll be showing you a different notebook. You can actually go to the notebook level 01, diving deeper into 1B and follow along. So I'll quickly restart the kernel and I'll run you through the code first. So in this demo, what we are going to see is we are first actually going to explore the Titanic dataset, which is a very nice dataset to get started with machine learning in general. So it's kind of like the hello world for machine learning. So I decided what better dataset to showcase weights and biases with than Titanic. So what first we will do is we will have to download the train and test CSV files from Titanic machine learning from disaster, this particular Kaggle competition. You can just go here and download the files and you can actually put them in this particular directory, in this particular data directory. And like you will see that the data directory is empty. I already have the train and test CSV files downloaded into my system. I'll just copy it from there. Just go to if you are on Codespaces or Google Colab or GitHub, Gitpod, you can actually similarly drag and drop your dataset from your local files to your VS Code workflow on cloud. So now that we have the train and test CSV files, of course, opening them and seeing them doesn't make a lot of sense, right? What first we are going to do is we already saw that how we logged a model artifact in the previous demo. This time we will be logging these two particular files as a dataset artifact. And we will see what it means to log something as an artifact. So if we quickly execute these two cells, it will start a run. And if you notice that this time I'm basically setting one particular parameter in it called job type. So job type is basically an alias which you can set for your jobs. Like oftentimes when I'm training a deep learning model, what I do is I set the job type train. So this basically later allows me to sort my runs using my job type or group them by or filter them by job types. Basically, this is basically helpful if you have a lot of experiments in your dashboard. So let's quickly jump to this particular run. And if we see there's nothing, we haven't logged anything. But if we go to the artifacts tab, we can see that there's a data set that has been created on weights and biases. And if we go there, we can actually kind of see that it has created an artifact. So what an artifact is basically, it's you can say it's a version directory or a version set of files and is immensely useful for versioning your dataset and your model checkpoints along complicated ML workflows. And if you go to the files tab, we can actually see the CSV files there. And if you want to use it in your ML workflow, it's as simple as copying this bit of code and pasting it to your workflow. And if we come back and restart our notebook, what I'm going to do is run the next bit of code, which basically demonstrates how data versioning is actually useful in experiment tracking. So here I basically start a new weights and biases run. And I actually use the code that was present there under the usage tab. I basically copy pasted them and fetch the artifact. So if you run this code, once it finishes running, you can actually see that there's a directory called artifacts, which has automatically been created. And it has actually automatically fetched your dataset for your usage. So once your dataset is fetched, we will use pandas.read CSV to load them. And what I'm basically doing, I'm slightly modifying the data. So what I'm doing is in the train CSV, I'm basically adding one additional column, which is basically going to show which particular split, the training split or the validation split, a particular data point belongs to. So some pretty no-brainer pandas code I have written here. And I have saved the modified train.csv to our data directory again. Now, if we execute this bit of code to again log it to the same artifact, and if we go back to our weights and biases artifacts page and refresh it, we can kind of see that there's a version 1 of it that has already been created, which contains the updated data. And funny thing is, if we go to the lineage tab, we can kind of see which run created which version of this particular data set. And this version 0 was again consumed by this particular run called fresh wildflower floor, fresh wildflower 4. It's a randomly generated name which you can change if you want, and this is of type log data. Again, I said the alias job type, and this is basically producing the artifact Titanic v1, which is the next version of this particular data set.
Quick question: why would we care about this lineage? Why is it important?
We will see soon.
Okay.
I'll quickly restart my notebook and import the libraries again and see how we can basically use weights and biases to explore our data set right now. So exploring our data set using weights and biases is actually pretty no-brainer. So we again initialize a run. We again copy paste the same lines of code from the weights and biases artifact usage tab. You can go to the usage tab for v1 and you can basically copy paste this here, and I have done that exact same thing. I read the data frames again, and what I do is this time I wrap them around 1b.table. So wrapping a data frame into a 1b.table and logging them using 1b.log does some magic. We will see them right now, how this magic helps us. You must call 1b.init before 1b.log. Did I just call it? I must have restarted. Let me run it again. Dataset. I'll initialize the run again. And we are logging the tables. So now if we go to our dashboard, we can kind of see that 2 tables have appeared. Let's, for the moment, focus on the train val table. You can kind of see that it's, a little bit interactive and everything has been logged like this. The whole data set has been logged as a table, but what can we do with it? How about, the Titanic dataset is all about trying to predict whether a passenger is gonna survive or not. Okay, so let's see. Let's look at the data of all passengers who are below the age of 25. So for that, what we can do is write something like row of age is less than 25. And if I hit apply, voila, everyone below the age of 25. So now that I have seen, okay, I have filtered out a bunch of data points. I do not probably need this column, which I can remove. I do not need the name. I can remove it. I do not even need the cabin number, I think. What I can do is if I go in and if I hit group by using the split, you can kind of see that, it automatically creates a distribution with respect to the rest of the fields. You can see the distribution with respect to the gender. You can see the distribution with respect to age. You can actually zoom it and see if you want. You can see the distribution with respect to passenger IDs, although I do not think this is necessary. So maybe something like this. Cool, right. We just got all of this just by logging the data frame as part of the as a table, right? I'll show quickly a few more things you can do with tables. Is one of the things you can do is sort. You can sort in ascending or descending order with respect to any columns without having to write any code. We have already seen how we can write simple filter queries. We can remove columns if you want. We can add that particular column back if you want by going to insert one right, and if I go here, it has a column which I can just say as row of what I deleted was probably tickets. So I can add that back. Yes, I can add that back. So by deleting a column, you are actually not deleting the data itself. It's still there. You can delete it if you want for your own sake of visualization or presentation. That's all. But let's see if we can.
Quick question. So I'm wondering, what's the main use case of this? Is it like, let's say we run a model, we see that the performance is not what we expect, and we can try to dig in deeper to understand what's causing this, I don't know, dip in performance, right?
Absolutely. For example, take for example something like you have trained an image classifier, and you are basically plotting the predicted label and the ground truth label, and maybe you can check which of the cases the image performed badly by maybe a filter query like row of ground truth not equal to row of predicted, something like that, and many more. Tables support a lot of interactive rich media like images, videos, images with bounding boxes and segmentation masks. It supports raw HTML if you want to log that. But today we are basically trying to see what happens if you just pass in a data frame. But this is not just limited to what I have shown you till this point. I'll show you a few more things. Let's convert this table is a little boring. Let's convert it into some kind of combined plot. So it's automatically converting it to a line plot. Let's convert it into a bar plot and say I want to see the edge of all passengers, maybe. And voila, we have a bar plot of all passengers by ages. What if I go with something else? I can go with box plot. And okay, of course, box plot is not going to work on this kind of data. But does area curve show us anything? Yes, you can convert it into an area curve. Let's say I want to, change the run to something else. I want to change the color of the run to, let's say, whether the person survived or not. Can I do that? Yes, I think I can do that. And I go, yes, they survived. And if I hit apply, you can actually see it in right here without writing any particular piece of code, any kind of insights you want from your data. Can I change it to something like, let's say the class, and check whether they survived or not? Okay, the area plot doesn't give us a lot of insights. Let's convert it back to a bar plot and see. Well, yes, we can see based on the distribution of age and the classes, we can see like which classes survived how much on, or what was the age distribution along what class and what other classes. You can see that as well. Probably something like, let's say across something like 6 can give us a better insight. And yes, I think so. You can also change the color to something like edge, I guess. And will it show us something different? Yes. So it's again colored as per the edge. But again, enough playing with bar graphs, right? Let's see if we can create something more interesting or not. Let's try to create a combined 2D projection. And let's see, we do not need passenger ID. We do not need parts, let's say. And let's color by, again, whether they survived or not, which is source dot, let's say, survived. And I don't think in this case survived is needed here, and hit apply. And yes, we have a projection. And if you want, if you want to create the projection using something other than PCA, we can maybe choose TSME. Yeah, you can see here. And maybe if I remove age from here and put age here, maybe that's going to give us a better understanding. Oh, not so much. But okay, what if I put age back here and I put something like fair? Not even fair. Let's say something like 6 and hit apply. Voila, it shows us the distribution colored across different with the two different sexes altogether. So basically, to get more insight from your data, to ask different questions to your model, all you need to do is just log this data frame as a 1v.table, and 1v automatically takes care of a lot of the visualization you need to produce for exploring your data set and getting insights before going into the model fitting part, right? So again, similarly, you can do the same things on your test table also. It just lacks the survived column, I think. And okay, so for the time being, let's turn it back to a table and let's jump into the code. So someone kind of asked me, what is the use of artifacts? What is the use of creating these different versions and lineages? We will see it shortly. After basically we have fit a very baseline model. So what we are going to do with this baseline model is, like say baseline experiment 1, let's say I change the job type to train, and I'll be using the latest artifact, the latest Titanic artifact to basically train my model. And we will see what happens. Let me quickly restart the notebook and hit the training code. So training, and this time basically I'm using a little bit of a more fancier model with the help of random forest classifier. I'm logging a little bit of more metrics, for example, right from accuracy score to precision score, recall score, F1 score, and a lot of other classification related metrics I'm logging to weights and biases in the same way using 1p.log. And also I'm creating a few more visualizations like class proportions, summary metrics of our experiments, along with the precision recall curve, confusion metrics, and the ROC curves that we have seen earlier. And I'm also again saving the model as an artifact again. So now basically let us take a look at why this particular lineage would have been important. So if I go here, go to this particular run that we created right now, and if we go to the artifacts it created, you can kind of see this particular model artifact. And if I go to this model artifact, you can actually use it. If you want to use it in production, you can just use it. You can download it using this particular piece of code and use it. But here's the thing about lineage. So if I see the complete lineage with generated artifacts, we can actually see that, this how this basically the data set came about, which we are using it to train on. So let's say if I find that there is something wrong with the model I just trained, which is which one? Train, produced, table, and model. So this is the model artifact. So if I find that, okay, my model is not performing really well in production, it's not reacting well to new data that is being fed to it. So what I can do I can take some business decision. I can backtrack using this particular lineage graph you are seeing. I can backtrack it. I can see, okay, so this model was created by this experiment, which was created by this version of data. So what if we create some more modifications to this data set and there's another version of data, and then we basically train it across that particular version of data. So, for maintaining different versions of your code, you have GitHub, but GitHub doesn't version your data, right? You will have to use something like DVC, something like GitLFS, which are a little more cumbersome to use and also doesn't produce this kind of beautiful lineages. Weights and biases artifacts is way more easier to use compared to something like DVC or GitLFS. You can just use it with these 3 lines of code, and you have automatically created a new version of your data if there is any difference in your data set. Otherwise, it won't even log. So we created a baseline experiment, right? But let's again try changing something with respect to our hyperparameters. Let's say I change the max depth to 15 and I train this model again. I run this experiment again. I'll import my libraries and I just run my code again. And you can see that if you go into 1v.init, if you will see I have set the job type to train, and we will see how setting job types to alias your different experiments is actually useful when you have a lot of runs on your dashboard. So the artifact is saving, and the training is complete. So if I go back to my dashboard right now, I can see there are a lot of runs, but if I just want to check my baseline experiments, again, I forgot to change the name, so I can change it here. If you have forgotten to set your run name, you can always come back and change it from your Weights and Biases UI. What I want to do is, let's say I want to group by the runs, maybe by job type. And if I see the training and the training jobs, I should be able to see one particular log. And if I see it here, again, my original experiments are logged under a null job type because I hadn't set any job type. But how about, instead of grouping, how about we just add a filter that the job type is, training? Suddenly our dashboard looks a little less cluttered right now. So again, we can see all the experiments that all the metrics that have been tracked automatically as part of our experiment, as part of train and validation, two separate panels. Why does this happen? How did this happen? This happened automatically because here in 1b.log, I set train slash. So you can basically use a slash inside your training, inside your log keys, to basically create nestings inside your Weights and Biases dashboard. It basically helps sometimes to keep the training and validation metrics separately. And again, we have created some, I'll switch out the tables. We have created some more visualizations. I'll just quickly exclude them. And you can see here that the class proportions are automatically visualized along with the old metrics which we saw, including the ROC curve, the confusion matrix, and the precision recall curve. And all of these are, completely interactive curves which are logged automatically using Weights and Biases. So you can actually check our documentation, docs.1b.ai, which is also linked in the slides, to learn more about the utilities that you can use them for your scikit-learn or your Keras or your PyTorch workflows, irrespective of which framework you are using. So now kind of we have, explored a little bit of more advanced features of Weights and Biases. We can, let's go back to the slides and see what more Weights and Biases has to offer us in terms of experiment.
Before we do that, maybe we can answer a few questions. So there are quite a few of them. And like I see, I don't know, 1, 2, 3. Like there are a couple of questions about what is possible to do with the free tier and what is not possible. I assume that everything you showed us today is possible with the free tier, right?
Exactly. So the only difference that enterprise tier gets you is access to a lot more artifact storage. So right now, if you sign up for Weights and Biases under an academic account, or you are developing for some open source projects maybe, or some hobby projects, you can use Weights and Biases for free. You will get 100 GB of artifact storage by default. But if you need more than that, you will need to basically pay go into a pay per use model, or get in touch with our sales team to get you set up for your experiment, your enterprise requirements.
Mm-hmm. And if it's just a pet project of mine that I'm doing alone, what kind of restrictions, limits do I have? Like it's not open source, it's not educational, it's just, I don't know, I'm hacking something after work.
Nothing. Literally nothing. So only if you are using Weights and Biases for work, then only you need to pay, otherwise not.
Okay, that's cool. And in terms of the number of projects or experiments, again,
There's no restriction. Literally no restriction. Only the amount of artifact you can log, not the number of artifacts, mind it, only the amount of artifact storage you can use.
Oh, another question. Can I use weights and biases with text data?
Absolutely. There are, in fact, I would actually like to quickly open our docs and show you something called prompts. So we are actually integrated with all major, LLMs like Llama Index, like OpenAI, with LangChain. So if you are using maybe LangChain for with weights and biases, you can get trace tables and some fancy visualizations there as well. So weights and biases is not, I would say, data type, restricted by the type of data you are working with. We are completely framework agnostic, completely agnostic with respect to the type of data you are using, or even the type of data you want to log, or the type of media you want to showcase. It's completely up to you.
Yeah, nice. Thank you.
Any more questions?
Yeah, there are a few more questions, but I want to keep them till the end.
Good. I'll basically go with the next portion of the weights and biases journey that I wanted to share with you, is basically training better models. So how do we train better models? Like we have, you already saw me perform a few experiments, few baseline experiments, but always the question is, can we get more out of our machine learning workflows? And one way to do that is, to use some kind of hyperparameter optimization system. So weights and biases has its own hyperparameter optimization system that is built inside the product. And again, this is completely free. You do not need to pay to use hyperparameter optimization with weights and biases. Basically, the hyperparameter optimization system that comes as part of weights and biases is called sweeps. And sweeps automatically comes inbuilt with some of the latest cutting edge hyperparameter optimization algorithms like Bayesian optimization and hyperband and a few others automatically inbuilt. And, they give us some interesting insights with respect to not only just our hyperparameters, but a lot of different aspects of our model workflow. So how it works is basically you only have to define your particular sweep config, what we say. And what you define as part of the sweep config is basically an alias to the algorithm that you are going to use, which in this case, for example, it's bias, which refers to the Bayesian optimization and hyperband algorithm. You have to define which metric you want to optimize for and what is your optimization goal. So for example, you want your sweep to optimize for minimizing the validation loss. You can optimize for maximizing, let's say, your validation accuracy, something like that. And then basically we come to the parameters, actually the hyperparameters themselves, which you will basically define the ranges we are going to sweep them for. So for example, like in this case, the batch size, we can actually sweep from the values 34, 32 and 64. You can also define ranges of values in which to automatically sweep from. And once you have your code, which is instrumented with weights and biases, and your sweep config ready, you can initiate your sweep. I'll show in a while how, but I'll basically tell how sweep actually works is basically in two parts. One, there is the central sweep server, which lives on weights and biases site, and then there's the agent, or agents, should I say, which live on your end. So what these agents are basically, you use these agents to control your sweep. What that means is basically, let's say you are, sweeping over a very large deep learning model and you want to run, let's say, hundreds of runs, hundreds of iterations of sweeps. You can actually run 3 or 4 different agents over 3 or 4 different GPUs or over 3 or 4 different computers itself. So that's one way. Basically, agents help us to parallelize our sweep. And what the central sweep server lets us do is it provides us with a dashboard which lets us control our sweep right from our weights and biases dashboard. So let's say we are running our sweep and something goes wrong, or maybe we just want to stop the sweep somewhere. So we do not need to go into individual terminals and press Control C. You can just go to your 1B sweep server, which automatically creates a dashboard for you. You can go there and you can kill the switch, or maybe stop the switch. You can pause the switch, you can resume the switch, and do a lot of things with your sweeps. And basically, I would like to show you a little bit about sweeps right now, how it works. So if
Does it work without weights and biases? Like, let's say if
sweeps,
I want to use it standalone.
No, sweeps is a tool that's been built to work with weights and biases itself. It comes, you do not have to install a separate third-party library like, maybe Keras Tuner or Optuna that are out there. There are other third-party libraries also. You can, in fact, use some third-party libraries like Keras Tuner and Raytune with weights and biases sweeps to get the visualizations and use their engine. But I have always found the best experience is if you use the sweep engine, hyperparameter optimization engine, as well as the visualization and the insight sweep gives you. So I'll basically run you through how you can basically create and run your own sweep. So in the previous notebook, we kind of basically saw, we basically wrote a baseline experiment, instrumented with weights and biases logging. What we do in this case is copy all those code and put them into a function called run train. And then what we do is basically we make a few changes. So for example, we now have to get the configs from our individual runs, which are spawned by our central sweep server via our agents on our systems. Okay. So a clarification, the sweep is actually not going to run on weights and biases systems. Weights and biases central sweep server is just there to control it. Wherever you run your agents, be it your local system like or be it on your code space, be it on your Google Colab, or for example, I'll run it on my GCP instance. You can run it anywhere, but you can control it from your weights and biases central sweep server. And what we are basically trying to find out is basically a couple of optimum set of hyperparameters for training our random forest classifier. And we will get these values from the config, which is produced by the run itself. So what's gonna happen is I have already shown you how you can write your own sweep config. So we have basically written a few hyperparameter search spaces, let's say, for max depth, for number of estimators, for a bunch of other things. Note that they can both be continuous distributions as well as discrete values. For example, these are discrete values while these are continuous distribution. And you can in fact change the type of distribution as well. For example, I want this to be uniform integer distribution, so I set it accordingly. You can change the distribution if you want. And what happens is basically you first create a sweep ID by calling 1b.sweep on this particular sweep config. What it does, it actually creates your sweep. It actually creates your central sweep server on your weights and biases dashboard. And then basically when you call 1b.agent, what happens is you pass in that particular sweep ID to this particular agent. You can in fact spawn multiple agents and parallelize your sweeps across multiple runs. And you call this function run train. So this function run train is actually will be called by our agent 5 times, as I have specified. And what will happen is the central sweep server will actually try injecting values inside the run train function by virtue of this 1b.init. It will basically inject this particular configs, which will basically train the model, and we will see if we are optimizing towards the best set of hyperparameters or not. Now, as you can see, like running this sweep for nearly 5 times is not going to be very effective. I'll just run it. It's going to take a lot of time. But what I want to do is I want to show you what if you run this sweep for, let's say, 30 iterations. All you have to do is just change this to 30. And I actually have a project where I have actually run it for 30 iterations, which I want to show in this case. Yeah. So there's this project which I have already run, as you can see, multiple sweeps, and I'll show you basically the results of both the Bayesian sweep and random sweep. So random sweep is basically, there's no particular algorithm. It's basically randomly trying to, the sweep optimizer is basically randomly trying to find a path in the search space, you can say, in the hyperparameter search space, and seeing which hyperparameter optimizes better. And Bayesian sweep, on the other hand, has a proper objective which it's trying to minimize. I'm not going into the details of how the BHOB, the Bayesian optimization and hyperband algorithm works, but we will see their results and how we can use them with sweeps. So if I go to this particular sweep, we can see the usual media, but we won't need to look at the media. The important things are basically here. So I'll just make this charts a little bigger to show them to you better. Yeah. So as you can see, this sweep has actually automatically created 30 runs, and it has been trying to optimize slowly for maximizing our validation accuracy. And you can see it has been running so many runs, and every time like it's trying to maximize the validation accuracy. And finally, like we got kind of our best model at 0.8436 with that kind of validation accuracy. Maybe if we run it longer for more iterations, we could get a better version of our model. And here, let's basically look at this particular chart, which is the parameter importance chart. So this is actually quite an interesting chart. And these two charts, the parameter importance chart and the parallel coordinate charts, are what, in my opinion, makes sweep such an interesting tool. In fact, one of the most interesting tools in the weights and biases arsenal is that you do not have to take a best set of hyperparameters. Like, it's not a black box, and it's not going to throw you a best set of hyperparameters which you just have to take for granted. You can treat it as a black box if you want, but the best way to utilize sweeps is basically using this particular charts to actually analyze different trends of your hyperparameter. So we can see here, right, that the parameter bootstrap actually has a high negative correlation with respect to the validation accuracy, which means when we set bootstrap equal to false, we tend to get better results with respect to, or we tend to get better validation accuracy. So something like that, if we try to see here, if you see bootstrap, the runs here, and if I try to filter the runs which give the best validation accuracy, we can kind of see that's kind of the case, or even kind of not the case also a few times. Like a lot of the times, like the sweep chose the bootstrap to be false, and it got the best results, but it's not giving us a complete picture. So let's try to look at the next set of parameters for the parameter importance. If I remove this section and if I see, it says max depth. So max depth has a high positive correlation with respect to the validation accuracy, and kind of seems intuitive. Basically, it's the number of it's the maximum amount of depth you let the decision tree inside a random forest to reach. So the deeper the tree, the better it's fitting the data, probably. That's why it's learning. So if I kind of create a filter among the higher reaches of max depth, I can kind of see that it kind of starts making sense. So accordingly, if I choose something like the number of estimators to be as high as possible, and okay, what does it say about warm start? It says that there's a negative correlation. So I can kind of figure out that I'll probably have to set my filter here. So if I filter out the runs here, somehow this is not working. Some UI issue might be, and we can kind of see that it kind of makes sense. Like a lot of the runs which had warm start equal to false actually made up to give the best validation accuracy. In fact, the run with the best validation accuracy had a warm start equal to false. So this way, basically, you can interactively analyze different trends in your hyperparameter and make important decision with respect to which model you need to take to production. So oftentimes, if you're training a deep learning model, it happens, the biggest model gives you the best accuracy, but you cannot take the biggest model into production. You need to come to a trade-off with respect to the size of the model and the performance of the model. So sweeps is a tool that can, let you take these kind of crucial business decisions with respect to which model you want to take into production, or how to get the most out of your models by doing hyperparameter optimization, and not just, getting the best set of hyperparameter to train the best model.
And there's a question that is relevant to what you're talking about right now. So we have two things. We have the correlation one, and we have importance, right? But what we're interested in is probably kind of multiplication between these two, because something could be correlated, but maybe the importance is small, and then like practically we don't really care about that thing.
Yep.
Right?
Yep.
Is there a way to somehow see this combination here?
I would say right now it doesn't exist. So there's probably visualizations which you can make using Matplotlib into weights and biases and log them into weights and biases, which would be automatically converted into these interactive charts. So if you, let's say, make a want to plot a correlation matrix somehow using Matplotlib, like all you need to do is just 1v.log and pass your plot, and it will be automatically taken here and converted into an interactive chart. So you can do that as well.
Do you have an example somewhere?
We don't have an example right now.
Well, if you come across an example, then please
I'll share it. I'll share it.
Do it in the description.
Yep. Any other questions?
Not about this one.
Okay. Shall we continue, or
yes?
Shall we? Sure. So yeah, basically we kind of saw how this helps us a lot, right? But then basically we come to the other aspect of why we do experiment tracking. So there were three aspects, right? Sharing our results, reproducibility, and making crucial business decisions. So we kind of have already checked how reproducibility, in terms of reproducibility, weights and biases helps us, how in terms of, how in terms of making crucial business decision it helps us. Oh, I wanted to show you one more thing in this particular sweep. So for example, in any run, if you go to the overview, you can actually see, I think, which artifacts were used to create this particular run and which artifacts it created. So that way as well, you can, keep track of your lineages across multiple runs, multiple experiments, and however complex your workflow gets, that artifact lineage always will have you covered. So yeah, I just wanted to move on to the other aspect of experiment tracking, which is unified reporting and dashboarding, which basically is one of the best ways to share your results and publish your ML results using a tool that we have called reports. And let's take a look at how we can create a report and share and present our works. So I'll quickly move on to this particular report, and I'll go back to the dashboard. You can see there's this report icon. If I click on it, or even rather, if I go back to the sweep and I want to share, let's say I want to share this particular plot, right? I can do that using a report. So what I can do is I can add it to a report. I can, I can create a new report. I can add it to a report. And voila, I have a report created. And writing a report is kind of like writing a Notion doc if you have used one previously. So I can say this, my fancy sweep, and I can add my headings. I can add more panels as well. For example, if I want to add a panel grid, see, it's just like Notion. I want to add different set of experiments. So let's say I set a filter here. Again, you will see why setting job type can help us a lot. If I set here train, I can import everything. So I can import all these charts here. I can import all the validation charts here. And I can say basically this is, can rename this to be baseline experiments. Let's move this to the top. Why isn't it working? Because I've zoned it so much. Okay, so if there are multiple sections, you can actually move them, but maybe due to some issues, cannot get it to work. But yeah, okay, no issues. Let's see if we can do something else. Like you can add bulleted list, you can add images if you want, maybe add an image here from your local system and do a lot of things. And reports is not only a really good way to share your work with your stakeholders, with your business, which enable you to take a lot of business decisions. It's a great way to present your work as well. So I kind of would like to share you a few reports that I myself have written. So I'll just go to my 1D profile and show you maybe something like object detection. There was this particular report I had worked on last year, so which basically shows how you can use sweeps and artifacts to actually create the best object detection algorithm for, create the best object detection model for taking into production. So I'll here like to showcase one nice thing in this particular report is how images look inside tables. So remember I said tables are basically rich data frames with rich media formats, and you can see that these images are actually rendered inside these tables. So let's say if I want to, let's say, explore this particular image, I can go here and see, and you can see all the bounding boxes and the semantic segmentation masks here right away. And you can in fact interact with these labels also. So let's say I want to switch off the traffic lights. Let's say I want to switch off the segmentation maps and want to focus on the objects. I can switch off the cars. I can search for something like, let's say, truck. Is there any truck here? Yeah, there's a particular truck I can see. And again, the same things with the semantic segmentation masks as well. Like you can switch off the road. Maybe again, try to find a truck here. The truck is not annotated, or the model is not predicting it. You can go for the cars. And yeah, like you can do a lot of cool things with tables like this. And if you are training, irrespective of what kind of data you are using to train your model, be it tabular data, be it something like, as we saw just now, images, videos, be it text. I in fact work a lot with images, to be honest. That's why my reports are kind of geared towards computer vision a lot. Tables and artifacts has always got you covered. For example, let's say this data set I'm using for training, right? So if I kind of group them by weather, I can see important things like this column. I can kind of see that, okay, we need to annotate more images of parking spaces. So this way, basically, you can actually take crucial decisions about your data set as well, not just your model. So yeah, that was something I wanted to share. If you are into generative AI, I have a report here as well. Like, I'll just say, like, reports are one hell of a cool way to write machine learning blog posts in 2023. Like, you don't have to create, just take screenshots from your demos or anything like that. You can embed your demo right inside a report. You can, let's say, for example, this one uses stable diffusion, this particular demo, and we can actually see how this image is diffusing out of pure random noise by using this particular slider. And we can see how the image is how the model is slowly generating the image itself. I'll just give you a disclaimer that 1D itself doesn't do any kind of machine learning on your images. Like, it's not going to generate this image for you. You have to generate the image yourself. But what we can help you do is we can help you basically log and visualize your workflows a lot better and cleaner, probably than some traditional experiment tracking workflows. So yeah, that was kind of something I wanted to show you. And if you want to read more reports like that, I'll also point you where you can go and read more such report. And A lot of the time I get this question like, how do I use weights and biases with framework X on platform Y? And I think I have already kind of clarified on the platform Y type part, which you don't need to worry about the platform where you are installing or running weights and biases. It's platform agnostic. I would love to say it's framework agnostic, but it's a little bit more complicated than that. For example, a lot of the frameworks like Keras doesn't have, workflows to directly call 1b.log. So you have to use something like callbacks or something like that. So technically, weights and biases or any other experiment tracking tool technically are framework agnostic. But basically, what we do is we try to create integrations, easier to use integrations with most open source frameworks that are out there, and you will find these integrations with more, if not all, then at least most of the important ones which you would probably end up using, including PyTorch, Keras, scikit-learn, as we just saw today. The Keras integration is something which I personally maintain and develop actively. We are also integrated with, YOLO, OpenAI, NVIDIA NeMo, NVIDIA MonAI, and a lot of other open source repositories all across the whole open source software space out there. And you can also find weights and biases often comes with a lot of cloud offerings. So for example, you can actually find weights and biases as an offering as part of your cloud marketplace in GCP, on AWS marketplace, on Microsoft Azure. So if you want to get a enterprise seat on weights and biases, you can actually purchase them from these cloud marketplaces as well. So yeah, this is probably one question, the most recurring question which I find people asking me: how do I learn more about weights and biases? Because weights and biases has so many features which it's not technically possible for me to cover within a short amount of time. So I would wholeheartedly suggest you check out our documentation and our tutorials which we have prepared for you to get started easily. You can also read more machine learning reports like the ones I demoed at Weights and Biases official blog, which is called Fully Connected. And in order to know more about how Weights and Biases integrates better with your MLOps pipelines and workflows, you can check out the free courses that we offer, the effective MLOps model development and model development, CI/CD, and LLMs, which are a few courses which are upcoming. You can just sign up at 1b.courses and get a free certificate if you complete these courses. And if you, of course, if you want to get access to the homework, I think Alexi has already shared the link. I still included the link here and the QR code. If you haven't received it, you can just check it out here. And should I mention that the winners are going to get some weights and biases swags, such as the one probably I'm wearing myself.
You should definitely mention that, yeah. So we will have weights and biases offered as some swag, some merchandise, t-shirts, right, with weights and biases logo, and we'll have a raffle. So if you submit the homework solution, then we will randomly pick some of you to get the t-shirt or other swag, right? I don't exactly know what it is. Maybe you have some mugs or other stuff. It will be a surprise, right?
Absolutely. It's going to be a surprise.
Okay.
Completing the homework should be fun, not, you shouldn't be chasing after marks.
Yeah, of course. Well, one question that I see it was asked like a couple of times is how does weights and biases compare to MLflow and other things? But I think for us, for those who take the course, comparison between weights and biases and MLflow is the most interesting one, because in the course we have already seen MLflow, which is an open source thing. You need to host it yourself, and then now we see weights and biases, which is something you don't necessarily need to host yourself, right? This is a cloud offering. So what's what are the differences?
So one of the first things, like Alexi, you clarified, MLflow is something you need to host, which makes it I won't say it's not super challenging. I would say but it's a little bit of barrier that you need to host it in order to share your work with someone. But then again, with weights and biases, you get a lot of advanced features. I guess which you do not get as part of MLflow. One of the coolest things about MLflow I like very much is the model registry. In fact, weights and biases has a model registry which is similar to MLflow, which I would have loved to cover, but unfortunately, due to lack of time, it won't be possible to cover everything about weights and biases. But I would basically probably draw the conclusion in a TLDR that weights and biases is more of an enterprise scale product, which is used by larger teams, smaller teams, hobbies. It doesn't matter. MLflow is something typically I think you would use if you have too custom of a use case. I cannot guess why someone would need two custom, because at the end of the day you can log anything you want to weights and biases. But maybe if someone needs to host it and themselves, and the price might be a barrier to some people. So maybe for small startups who do not have enough funds for weights and biases, I would guess they can go for MLflow. But yeah, like that's basically more or less. MLflow is a really cool tool, I would clarify myself. Of course, weights and biases and MLflow are very similar in a lot of respects, but yeah, they are also a lot different in a lot of respects. But the differences come mostly in terms of what one tool has to offer and the other tool doesn't. So what I recommend is you go to the weights and biases docs and you visit the links that I shared you. You check the weights and biases offerings. If it matches with your requirements, you can take a seat, or you technically you don't need to pay anything to get started with weights and biases yourself or to complete any of the homework. So there's no point about that. But yes, at the end of the day, I'll recommend like you can check out the offerings of both the tools, and based on your workflow, your requirements, and your budget, you can take a decision which one you want to buy if it's for an enterprise use case.
Thank you. Another question, which is somehow related. So in MLflow, there is a there is a way to automatically log things. It's called autolog. So you just say autolog, and then you don't basically need to do anything. The MLflow just detects everything you do and then logs it. Is there similar similar functionality with weights and biases?
I would say no. And the reason is actually pretty it might not be pretty apparent, but it's more of a design philosophy kind of thing. So MLflow is something, as I said, like MLflow has been designed so that you can spin it up locally and get started quickly. And weights and biases, on the other hand, is basically something which gives you a lot of things and also gives you the low-level control to do those lots of things. So for example, if you are working with, let's say, Keras or PyTorch Lightning, using weights and biases is just one line of code, including one callback into your workflow. But if you are trying to do something custom, you can again make use of all those low-level functions, be it 1v.log, 1v.artifact, or anything you want. It's automatically you can include them in your workflow if you want to or not. What basically we encourage at weights and biases is that you whichever function or whichever framework you are using, you would probably find an integration with us anyway. So this is something I would clarify very much. So I stuck to tabular data because MLOps Zoomcamp revolves a little bit around tabular data mostly, but weights and biases is a tool which shines the best when you are using it for deep learning applications, where you have to train for a lot of times. When you have to train longer, so you have to store your model checkpoints to analyze later, and there's a lot of surgery going on inside your experiments, your data, your models, and a lot of other things. Those are the kind of use cases where weights and biases shines better. Maybe for the other use cases, if you feel like you can use MLflow as well. And I would like to mention this. So earlier I mentioned that TensorBoard is something that is one of the traditional ways to track your experiments, albeit automatically. So there's this particular offering in weights and biases. If you are using TensorBoard, some advanced features of TensorBoard which may not come out of the box as part of weights and biases offerings, instead of building a weights and biases integration yourself for that particular visualization, what you can do is in 1b.init, there's a parameter called sync TensorBoard. You can just set it to true, and automatically your TensorBoard instance would get hosted inside your weights and biases run.
Okay, cool. I don't see any more questions, so thanks a lot for your presentation, for your demo. One thing I want to mention is probably some of you will have questions as you try to practice. Some questions will come up. And if you're taking the course, you can just go to the course channel, which is Course MLOps Zoomcamp, and ask your question there. And if you're not taking the course and you join this webinar just to learn more about weights and biases, yeah, you can also ask questions there in the course channel. So I think it should be fine. But I have a question to you. Is there a community? Do you have a community where these people, let's say the course is over in a couple of months, and somebody stumbles upon this video and want to ask a question? What's the best way of reaching out to you and asking a question?
Great question, Alexei. So anyone can basically join the Weights and Biases Discord server. I'll drop a link in the Slack. You can forward it to the participants of the course or anyone who is there on the Datatalks Slack server. So Discord is basically the best way to reach out to any Weights and Biases community member or any even us Weights and Biases employees are there. You can basically reach out to us at any time. Okay. We have a very nice thriving community, so you can be a part of that as well.
Okay, definitely do that. When you share the link, I will post, maybe just send me the link too. I will post it. I will put this in the description of this video. So then later, because we have a free version of Slack, after 3 months, all the messages will be gone.
Sure.
So just to make sure that the link stays there, I will put it in the description. And yeah, I think with that, we probably should be wrapping up. So thanks everyone for joining us. Thanks Soumik for the awesome demo, and have fun doing the homework. So the link to the homework is in the description. Remember about swag, and yeah, that's all.
Thank you, everyone.
Thank you, everyone, and have a great day.